Hi everyone, welcome to this very important chemistry class where we are going to look at the language of chemistry. So this is one of the most important classes where we understand, what are atoms, molecules, all these symbols, you see all these formulas like H, H2, H2O, what do they all mean? O2, right? So we are going to discuss this. I'm going to make the concept super simple, but you guys have to promise me that you are going to learn all the important symbols, valencies, atomicities. So I have some important charts on that also that will help you, but please learn it from your book as well. So is that a promise from all of you guys? So let's dive into this topic, the language of chemistry. But before I begin, I just want to say, do check out the other courses on our website. We have physics, chemistry, biology and maths for CBSE class 8, 9 and 10. So guys, if you haven't taken the other courses, do take them and please do share it with your friends. For ICSE students, we are having courses like physics, chemistry, biology and maths for classes 8, 9 and 10. So once again, do check out the other courses and do share it with your friends. And if you want to learn coding, we have Python programming, we have Java coding. So all these awesome coding courses are there. And then we have physics and chemistry for the Cambridge IGCSE, which is the international board. So please do share out our courses with your friends. Make sure you have subscribed to our YouTube channel. You can also follow us on Facebook and Instagram. So keep learning. So first, let's start off with, we talk about matter, right? What is matter? So everything that you see here, is it matter? For example, water is matter, chair, the pizza that we eat, juice, all the things around us is matter, right? You and I, are we made up of matter? Yes or no? The tables, the chairs, all the things that you see around you, they're all matter, because matter means something which has mass, something that occupies space. That is called matter. Can you give me an example of something that is not matter, guys? What do you think? Absolutely right. So that's what, like emotions, like happiness, sadness, love, hate, these are not matter. Energy like light, heat, this is not considered matter. But the rest of the stuff that we are looking at, we know it's all matter, something which has mass and occupies space. Now, do you guys know that matter is not continuous? From our current theory in science, matter is said to be made of tiny, tiny particles, right? So for example, if we consider this large river, so if you take this river, we take out the water from the river, we put it, let's say, into a glass. So we take this water from the river and put it into the glass. Now let's see if we can go smaller than that. So if we take this glass, right, and we zoom in further, you can consider one tiny drop of water. Now if you zoom in further, the drop can be subdivided into smaller and smaller things, right? So when we go into smaller particles, finally, what do you guys see over here in this picture? If this is oxygen and these are hydrogen atoms, what do we have here, guys? This is nothing but H2O molecule. Fantastic. We have a water molecule here. So the scientists said that you can subdivide the matter into tiny and tiny particles, and this has all the properties. It is still water. That means I can drink this molecule. If you taste it, it will be tasteless, odorless, right? It is transparent. Of course, molecule is so small that we can't see it, but matter is made up of these tiny, tiny particles. And then, when we subdivide it, we know it is made up of these atoms like hydrogen, oxygen. You guys might have heard of this. And so here we come down to the atom level, where we are looking at the hydrogen or the oxygen atoms. So matter is made up of very, very tiny particles. So you can go from this big macroscopic journey. We started with the river and ended up with these tiny particles called atoms. If you don't know what are atoms, molecules, don't worry. That is the language of chemistry which we are going to discuss so that we can speak the same language in our chemistry classes. So matter can be divided, right? So we can classify matter because matter is everything around us. So in chemistry, as a scientist, right, we want to make classifications to make the study of matter easy. So we can divide matter into pure substances and mixtures, right? So matter can be subdivided into pure substance which contains elements and compounds. Again, if you have not heard of these terms, don't worry, you'll be learning this all in chemistry class. This is just the overview. Now, what are elements? Elements are things like which are made up of only one type of thing, right? So only one type of atoms. So where you can say metals, non-metals, metalloids, noble gases, all of this, right? So like for example, gold is a metal. It's an element, the simplest substance. Then you can have compounds. Compounds are made from elements like hydrogen, oxygen, they combine to form water. And then if you look on this side, we have mixtures, right? So here we have pure substances which are made up of only one type of particles. But in mixtures, you have, different kind of particles that are mixed up. You can have homogeneous mixtures where it is uniformly mixed and heterogeneous where it is non-uniformly mixed. So this is a good, understanding at a high level of how we can subdivide matter. Again, we'll be learning all these details in the chemistry class. So if you don't understand these terms, don't worry about it right now. So first we'll start with the basic thing which are called elements. Why elements? Because elements are the simplest substances, like elementary school simple. So these are the simplest form of substances because they are made up of only one type of particles. For example, if you take hydrogen, hydrogen contains only hydrogen particles, or what we call as hydrogen atoms or molecules. We'll look at that, right? Similarly, if you go to helium, neon, right? So that also contains only one kind of particles. And how many elements are there? So this whole world, this whole universe is made up of total how many elements? Do you guys know? So if you guys look at these look like roll numbers, but they are actually atomic numbers. They have a certain meaning, and you can see the last number. Don't look here. Here it looks like 103. The last number is right here, 118 elements. So this whole universe is made up of 118 elements, the simplest substances. And what is this picture that you guys are seeing here? This is called the periodic table. This is the periodic table of elements which they are classified into these periods and these groups which are columns, so rows and columns. And again, you'll study all about this in chemistry. So we have been talking about particles, right? Matter is made up of tiny, tiny particles. Now these particles we can divide into different types. So there's not just one type of particle. Particles could be atoms, they could be molecules, or they could be ions. And I'm going to discuss these in today's class. Let's take a simple example. So let's say if you have hydrogen, okay? So if you take hydrogen gas, if you take one atom of hydrogen, that means the tiniest particle which has all the properties of hydrogen and takes part in a chemical reaction, that we represent using the symbol. So all of these are chemistry symbols. So hydrogen, we don't have to write the whole word, we just simply write H. Similarly, for sodium we write Na, magnesium we write Mg. So please learn all the important symbols. You don't have to learn all these 118. Even I don't remember all these 118, but you need to know all the important symbols in the periodic table. Usually it is still, calcium, but then you have also iron, nickel, all these copper, important symbols which are all given in your book. So if you take the example of hydrogen, so if you're talking about the hydrogen atom, how do we represent it? With the single H, okay? That means I am talking about one atom, one tiny particle of hydrogen. Can you see it? No, it's very, very small. Not even observable under a microscope, guys. You need an electron microscope, not the simple microscope that you see in the laboratory or you see in the hospitals, right? Not that. We are talking about electron microscope. So very tiny particle. Now if we are talking about the hydrogen molecule, as we'll discuss, is made up of two atoms of hydrogen. So should I write like this, 2H? No. So in chemistry, it's very specific. The hydrogen molecule is represented as H2, and we'll see why. Now if I'm talking about the hydrogen ion, so one important thing is atoms and molecules have no charge. That means they have zero charge, they are neutral. But ions are charged particles. They are positively charged or negatively charged. So you could have a hydrogen ion. So that is represented as H+. So here I am giving you an overview of how the particles in chemistry look like. Even if you don't understand all of this perfectly now, it will all be clear in this class and in our future classes. So if you take the simple example of hydrogen, this is the hydrogen atom, H, one single atom. if we combine two atoms, we get a molecule of hydrogen, which is H2. So it can be made up of one or more than one atom. Or if you take a charged particle of hydrogen, it is H plus. Similarly, if you guys take the oxygen example, what is the symbol of oxygen? Oxygen symbol is O, right? Not 0, O. So one atom of oxygen we represent as O. Now molecule of oxygen, that also contains two atoms. It is made up of two atoms. So we represent, very good, as O2. And what is the oxygen ion? So oxygen ion is actually negatively charged. So we represent it as O minus, but it has a charge of 2 minus. So I'm going to write O2 minus. Why 2 minus? All these details you will learn. Okay. So this is an overview of different types of particles, atoms, molecules, ions that you're going to be encountering, and they are very, very small, cannot be seen with the naked eye or with the microscope. So first let's talk about atoms. Atoms are the smallest particle that retain all the properties of the element. That is why it's very important, right? So if you have a hydrogen atom, it has all the properties of hydrogen. Okay. If you have a sodium atom, it has all the properties of sodium, right? It will have the same color as sodium. It will react in the same way as a sodium block, right? Of course, we may not be able to see the small particle, but it has all the characteristic property. For example, if you have an iron atom, it will get attracted to a magnet because iron is attracted to a magnet, right? So oxygen atom, same thing, right? And in chemistry, we denote the atom using the symbol of the element. So that is why we learned the whole symbol, so that we don't have to write the full word hydrogen. We just write H. Sodium, so sodium is natrium in Latin, so we write Na. Na doesn't mean some other symbol. So sodium is not SO, okay, Na. And all these symbols are either one letter or two letters, and the first letter should be capital. Like hydrogen is just one H. Sodium is Na. Helium is He. Okay. Chlorine is Cl. Oxygen is O. So what we are really representing here is, this is one atom of hydrogen. Similarly here, one atom of sodium, and so on. Okay. So there's one atom of chlorine gas. Atoms, usually they are considered spherical, so that's why I've drawn this circle. But normally when we write, we don't even have to draw the circle. So we have drawn it in this form of a ball here. So here you can see hydrogen, sodium, helium, chlorine, and so on. We are all talking about atom, which is the tiniest particle that has all the properties of the substance, and it takes part in a chemical reaction. Now, can an atom exist alone always? Sometimes it can, sometimes it doesn't. So it combines with other atoms of itself, or if it's very reactive, it will combine with other atoms of other compounds, other elements, right? So that is why we come to this concept of molecules of element. Because as I said, remember, atom may or may not exist independently. There are certain atoms which cannot exist alone, and one famous simple example is hydrogen. Hydrogen atom, it cannot exist alone because it is not stable. It needs a friend. So it combines with another hydrogen atom. So you can visualize it like this, like there are two balls or two spheres of hydrogen side by side. They are chemically combined. So this now becomes one molecule of hydrogen. Can you guys see? And now you can see why we represent it as H2. But please remember, you don't write the 2 here. That looks like an H square. It looks like a mathematics class. Do not write it here. This has a very special meaning. So we have to write it as H2 as the subscript here. So this is one molecule of hydrogen. But there are certain elements like sodium where the atom can exist independently. So if I talk about one molecule of sodium, it is the same as one atom. So here this is one molecule is same as one atom. So one molecule of sodium. But oxygen cannot exist alone. So there you have O2. Similarly, chlorine cannot exist independently, so we have Cl2. Here it is helium. Helium can exist independently, so one molecule of helium. So the important thing is, atom may or may not be able to exist independently, but molecules can always exist independently, always. That is why molecule is very important, because our world is made up of molecules, these which can exist independently by combining with atoms of the same type like here, or with other elements. So here you can see we are talking only molecules of the element. So for example, I hope there is oxygen in your room. So there is oxygen in this room. So does it exist as O or O2? Can you guys tell me? What are you breathing right now? So the oxygen gas that you are breathing right now, is it O or O2? What do you guys think? Super. So the correct answer is O2, because just what we discussed, the molecule is O2. Why it is O2? Those you learn in detail. Why not O3? Well, O3 is ozone. Why not just O? Because it cannot exist independently, right? So it is unstable. It wants to combine with another oxygen. So this is the important thing. The world is made up of molecules, and that is why molecules are important. Otherwise, we could have just dealt with atoms. Why talk about molecules? Because they can exist independently. But in some cases, like helium, it's a noble gas. It doesn't need to combine with itself also. Just one molecule is same as one atom. Okay? These are called monoatomic. One molecule, same as one atom. These are called diatomic. One molecule having two atoms. Triatomic. One molecule having three atoms. So this is the important concept, that atoms, molecules, both are tiny particles, but what is the difference? Molecule can always exist independently. That is why it may be made up of more than one atom. Clear? Very important. So that is why this chart is very important, and I'll keep showing it in my classes. Again, you don't have to take a screenshot. We'll upload the notes after the class, right? So when the recording is uploaded in a couple of days, all these notes will get uploaded. But if you want, you guys can take a screenshot and please learn this, okay? Screenshot should not just lie in your phone or your device. The screenshot should go here. That is a promise that you need to make, because these are very important. So what is this? We are talking about this table of atomicity. If you observe this table, it is telling you that one molecule contains how many atoms. For example, if you take a look at all the monoatomic things. Who are all monoatomic? Helium, neon, argon, krypton, xenon. So you can see all the noble gases are monoatomic. One molecule contains one atom. They are so stable. Even metals are monoatomic. Okay? Metals actually have a complicated lattice, but for practical purpose, we consider one molecule is one atom. So all metals like sodium, iron, we represent simply as Na. We don't have to write Na2, Na3 or Fe2, Fe3, right? So one molecule is one atom. Now you have the diatomic guys like oxygen, hydrogen, H2, O2, nitrogen, N2, fluorine, chlorine, bromine, iodine. These are called halogens. F2, Cl2, Br2, I2. They all are diatomic. One molecule containing two atoms. Then you have triatomic guys. Here simple example is ozone, O3. One molecule contains three oxygen atoms. Phosphorus, tetraatomic, P4. Octatomic sulfur, S8. Okay. So what is the meaning of atomicity? Atomicity means the number of atoms in one molecule of the element. So normally we talk about atomicity for elements. Sometimes in books it's given. If I ask you, what is the atomicity of water? Can you guys tell me? What is the atomicity of water? So number of atoms in one molecule, normally it is for elements. So how many atoms does water molecule contain? 2 hydrogen, 1 oxygen. 2 plus 1, 3. That's it. Correct? So the answer is going to be 3 here. But normally we don't talk about atomicity of compounds. We normally talk about elements. So you guys need to learn this table, because you need to know the molecule contains how many atoms. Why it's important? Because in chemical reactions we represent the molecules. Or in chemistry we tend to write molecules. If they ask you for atom, then you shouldn't write O2, then you should write O. So this is the difference. When you write O, you're talking about one atom of oxygen. When you write O2, you're talking about one molecule of oxygen. Clear? O versus O2, H versus H2. These are the most important examples in atomicity. There are many more also. You guys can check in your book or on the net. But these are the most important that I've given for your syllabus. So atomicity is the number of atoms present in one molecule of the element as we discussed. And so the useful rules which we talked about, metals are considered monoatomic. That means atomicity is 1. One molecule contains one atom. Usually solids can be written as monoatomic even though their atomicity may be greater than 1. So for example, if you take phosphorus, so rather than writing P4, sometimes we write phosphorus simply as P because it is a solid. So many times we ignore its atomicity, but P4 is the more correct version. Similarly, sulfur. Sulfur is octaatomic, S8, but many times in the equations you will see S. Okay, that doesn't mean it's wrong, it's just a simplification, it's a simple way to write it. You can write S8 also, but then while balancing you'll have to multiply everything by 8, you'll get large numbers. Okay, so usually solids you can write the atomicity as 1. Many gases have atomicity greater than 1, as we saw there. You guys observed oxygen, hydrogen, nitrogen, chlorine, ozone, these are all gases. So gases, they tend to have atomicity greater than 1, and we must clearly write that in the equations. But all noble gases are monoatomic. Why? If you guys know, noble gases or inert gases are highly unreactive elements. They are so stable that they don't even want to combine with themselves. So they are all monoatomic. Monoatomic means atomicity is 1. And atomicity is different from valency. So we are going to talk about valency. So please learn all these atomicity numbers, but please don't confuse them with valency. So I suggest to keep it separate in your brain. Okay, atomicity different from valency. And again, you guys have promised me, you guys must learn this table after the class today. Don't leave it the day before the exam. Please learn it right now. Great question. Can atomicity be like 50, 60? Well, there is an example I can give you. So class 10 students might know that C60, Buckminster fullerene. One molecule of carbon contains 60 atoms. In fact, do you know the diamond that is there in the jewelry? It is one gigantic molecule of carbon made of millions of atoms, right? It is like one huge big molecule which is bonded with all carbon atoms bonded. So yes, great question. Atomicity can be pretty large, but mostly in your syllabus you have till octaatomic. You have this example though in some of the books. Buckminster fullerene, atomicity is 60. One molecule contains 60 atoms. Great question. What is the reason for this atomicity? Why nitrogen is N2? Why oxygen is O2? These mysteries will get solved in the classes. It's all based on their electronic configuration, their stability. Remember stability, there's the duplet rule, octet rule, but I won't go into the details today. We'll all discuss it in our classes. Is diamond really one molecule? Yes, it can be considered as one gigantic molecule. Maybe it is in parts, maybe it's broken. But practically, if you take one large thing, it is like one big molecule because there is no end. Means it is all, if it's pure carbon, right? It is all just carbon atoms and nothing mixed there. Then next, let's talk about. So we have talked about atomicity, and atomicity I told you is mainly for elements. Sometimes you can get asked for compounds, but mainly it is just with elements. Now we're going to go into something interesting called valency. What is the meaning of valency? Valency is the combining capacity of an element with other elements. Like if you say, how many friends do you have? It's like, what is your valency, right? How many other friends you have, or how many friends can you, interact with or form a group? Same way here, valency is the combining capacity. Combining capacity of an element with other elements. So very, very important. So how one element combines with the other elements. For example, if you take, so let's understand this, if we take hydrogen and chlorine and we try to combine these two guys, okay, so scientists have observed that if you take hydrogen and chlorine, the formula that you get is, so one hydrogen atom combines with one chlorine atom, okay. Hydrogen chloride or hydrochloric acid. You have seen this formula H. Okay. So the scientists have said that valency of hydrogen is the simplest element. So we consider the power or the valency of hydrogen as 1. So hydrogen's valency is taken to be 1. Since chlorine, one atom of chlorine can combine with only one atom of hydrogen, they said therefore the valency of chlorine is same as hydrogen, only one atom are combining, so valency of chlorine is also 1. Now they tried to combine hydrogen and oxygen because hydrogen is the simplest element. So they said, okay, let's try to combine hydrogen and oxygen, and they found we are getting H2O. So can you guys tell me, based on this, what is the valency of oxygen? One oxygen atom can combine with 2 hydrogen atoms. So therefore valency of oxygen is 2. Awesome. If one nitrogen atom can combine with 3 hydrogen atoms, so they saw we are getting a gas like ammonia, N and H3. So can you guys tell me what is the valency of nitrogen? Because valency of hydrogen is 1. Nitrogen is 3 times powerful. It can combine with 3 hydrogen atoms. So valency of nitrogen is 3. Excellent. 3 is the correct answer. So this is the meaning of combining capacity, where we take the simple example of hydrogen, but you don't have to just necessarily combine with hydrogen. You can combine sodium and chlorine. Chlorine has valency 1. So sodium, also sodium chloride, it will also have valency 1. So this is the basic idea, that valency is the combining capacity of an element with other elements. And we have to learn these numbers. Okay. So you may say, why is it NH3? Why not NH2, NH4? Well, you have to learn the numbers, okay, so that you can predict what will be the formula when these two combine, or in what ratio are they going to combine. So you can see 1:3 here. Here the ratio is 1:1, one atom and one atom. So how the atoms are going to combine with other elements, this is very important. So here you can see it is not hydrogen and hydrogen, H and Cl. Here hydrogen and oxygen. Here hydrogen and nitrogen. So that is the important thing, combining capacity of an element with other elements. So see, we discussed, if you combine these two guys, you are getting hydrogen chloride. And so because both have valency 1, we get HCl. Similarly, if you combine hydrogen and oxygen, well, now you need 2 atoms of hydrogen because valency of oxygen is 2. So we need 2 atoms here. We are getting H2O. Can you guys see the H2O? The molecule looks something like this. So valency, can you see, is used for compounds, because what is being produced is not a simple element. It contains more than one type of atom. It is hydrogen and oxygen. So that is why it is called compound, made up of more than one element in a specific ratio. Can you see that? 2:1 here. Similarly, we said 3 hydrogens combined with 1 nitrogen. So we are getting ammonia, NH3. Nitrogen valency is therefore 3 here. So there we talked about valency numbers. Now let's talk about valency was the combining capacity. Now let's talk about ions or radicals. So what is the meaning of ions or radicals? Ions are basically the charged particles. So this is a very important thing. Remember, we said there can be different types of particles, atoms, molecules and ions. Atoms and molecules are neutral, no charge. But the important thing is ions are charged particles. Now charge means there are 2 types of charges, positive or negative. Okay. So certain elements take up a positive charge, they are electropositive in nature. Certain elements form a negative charge. How does the charge happen? By gaining or losing electrons. You have heard of these guys, negatively charged particles. So for example, if you take the hydrogen atom and the hydrogen atom loses an electron. So if it loses an electron, what does it become? It becomes a hydrogen ion, H+. Similarly, if the chlorine atom, it gains an electron, it becomes Cl-. Now you may be wondering why hydrogen becomes positive, chlorine becomes negative. Well, metals tend to become electropositive in nature, but hydrogen is a non-metal. But still hydrogen has a tendency to form a cation. Positive ion is called cation. Chlorine forms a negative ion, Cl-, by gaining an electron. And we represent the charge by putting it up here, H+, Cl-. Similarly, oxygen will gain 2 electrons. Why? Again, for stability. So these are all based on the number of electrons it already has. So it likes to eat 2 chocolates. It likes to gain 2 electrons and it becomes O2 minus. Similarly, nitrogen here. Nitrogen tends to gain 3 electrons. So it becomes a nitrogen anion. Now one important thing is, what do you call these guys? So this is called like hydrogen ion. Here we call it chlorine, but when it gains this thing, this is called not a chlorine ion, it is called chloride. This is a chloride ion. Similarly, this is called an oxide ion. This is called a nitride ion. Okay, so the name changes a bit. Nitrogen gives nitride. So all these names, all these valencies, all these numbers you have to learn. I know it looks scary, but don't worry. If you start memorizing it, you will find chemistry much easier. So please understand and learn these things. And one important relation you might be noticing here is that chlorine has a valency of 1. So it forms Cl minus ion. Oxygen has valency 2. So it forms a O2 minus ion. So this number is actually related to the valency. The charge is the valency of the element. Nitrogen, we saw, it has valency of 3, but it is 3 minus. It's a non-metal, so 3 minus. Hydrogen, valency of 1, H plus. Hydrogen can also form H minus, but we will not talk about that right now. So these ions, the charge is related to the valency of the element. Then you can have more, so normally we use the term radicals is now no longer used often, but ions, radicals mean the same thing, charged particles. Sometimes you might have these complex ions where basically there is not just one atom, there are multiple atoms. So for example, you have an oxygen and hydrogen atom. So when these combine, they form the hydroxide ion, OH minus ion, which we symbolize like this. So it is possible for the ion to be made up of more than one atom. What do you guys see here? Sulfur and 4 oxygen. So as you will read in chemistry, this whole thing together forms something called sulfate, and this entire combination has a total charge of 2 minus or a valency of 2 minus. So that is sulfate. Again, here you have nitrogen and 4 hydrogens. So this is an NH4 and valency is +1. Ammonium. So this is very good. Ammonium ion, sulfate ion. So you have to learn all these names, you have to learn all these numbers. So these are more complex ions which are formed of more than one type of atom. Okay, so I'm giving you an overview here. If you don't understand all these details, don't worry, just giving you a flavor of the language of chemistry. So then you'll have to learn, all these tables where you have all these positive radicals or positive ions, we call them cations. So you can see most of the cations here are metals or non-metals. What do you guys see here? So can you see potassium, sodium, copper, magnesium? So most of them are metals. And you can see if you take a look of any example, let's say if you look at calcium here, it is written as Ca2 plus. This is the symbol, 2 plus is the valency. So this is basically we are representing the ion. This is the charged particle. It has calcium has valency of 2 and it has a positive charge. How did it get the positive charge? By losing electrons, because atoms, molecules by nature, they are neutral. They must gain or lose electrons, charged particles, negatively charged particles to become ions. Okay, and these are important because this is how the compounds are formed. This is how ionic bonds are created. So this is all the positive radicals. Again, you can see monovalent, bivalent, trivalent, tetravalent. Monovalent means valency 1, valency 2, valency 3, valency 4 and so on. And you need to learn this. Some elements even have multiple valencies, like iron you can see Fe2 plus, Fe3 plus. So ferrous, ferric. So an element could have multiple valencies. So all these tables you have to learn. These basically deal with the ions and their valency numbers. Similarly, just like you have cations, you also have anions, the negative radicals. So here is another big list. Again, for your class, you may not have to learn all of this, but at least a subset you would have to learn. So make sure you guys look at these tables so you can see hydroxide, OH minus, chlorine, Cl minus. So things like, you have sulfide, S2 minus. So sulfur with valency of 2 minus. Okay. So these are basically the charged particles where we have represented their symbols and their valency numbers. So why are these important? Because if we want to write the molecular formula, so as we'll see here, all these tables are important because if you want to find out the molecule of the compound, we need to use these ions and write down the molecular formula. So let's go ahead and take a look. How do we do that? So let's start with some questions so that it will be a good revision of what we have done in today's class, and let's apply the knowledge here, right? So suppose we are asked to write the molecular formula of the following substances. Let's say nitrogen. Okay. So again, read the question carefully. It clearly says molecular formula. So for nitrogen, if I'm writing nitrogen, first question you ask yourself, is nitrogen an element or a compound? What is the difference? Element are the simplest substances. Compounds are made up of two or more elements. So is nitrogen an element or a compound? Definitely it's an element. There's no other substance, it's just nitrogen. So for elements, one important thing is, should you use atomicity or valency? So this is a very important rule. Please remember, nitrogen is an element, and one very important rule is that for elements we use atomicity. For compounds, formation of compounds, we will use valency, combining capacity of an element with other elements. So please remember that for compounds, use the valency numbers, okay? For elements, we will use atomicity numbers because number of atoms in one molecule of the element. Compounds, we will use the valency numbers, okay? So nitrogen is an element. So what will be the representation of molecule of nitrogen? So we know nitrogen is basically, the symbol is N, right? So first you have to know the symbol. But when I write N, am I representing the atom or also the molecule? So we know N is at least the atom, but is it also the molecule? The answer is no, because let's check. So if you guys go to the atomicity table, where is nitrogen? Please find it here. Because we need to know one molecule contains how many atoms. For that I need to look up the atomicity. Nitrogen is diatomic. That means one molecule of nitrogen. There is nitrogen in your room because 78% of air is nitrogen. So one molecule, every molecule of nitrogen is containing 2 atoms. So it is N2, not N. So excellent. Many of you have given the correct answer. The answer is going to be N2 over here. One molecule containing 2 atoms. It is diatomic. Next question. Phosphorus, element or compound? Phosphorus is once again an element. So we are going to use atomicity. So the symbol of phosphorus is P. Now this is the atom, right? This is one atom, but we are asked molecular formula. So what should I put here? Should I leave it as P or what should I write? Fantastic. You guys have been listening carefully. The correct answer is P4. Now some of you are also saying P. That means you have been listening even more carefully. Very good. Because remember I mentioned for solids we could also write P. But when they ask you this direct question, better you write tetraatomic P4. Don't just write P, because P is an approximation simplification for the equation. So please write your answer as tetraatomic. P4 is the right answer. Next question guys. Write the molecular formula of potassium hydroxide. Again, don't get worried if you see all this. I'm just showing you how to apply chemistry, how to look at chemistry. So potassium hydroxide is the full name of the, is it an element or a compound? Clearly it is containing 2 things, potassium and hydroxide. So this is clearly a compound. Okay. So let me write that first. This is not an element. This is a compound. So how do I represent this? So for compounds, we are going to use valency numbers and do something very interesting called crisscross. So what do? Potassium is an element, K. The symbol is K. Hydroxide, the symbol is OH. Now how do I combine them? For this, I need to know the valency. Okay. So what is the valency of potassium? If you guys don't know, don't worry. Let's look it up in the table. So potassium, you guys can see here, it is monovalent. It's right here. Valency 1 plus. So valency of potassium 1 or 1 plus. Hydroxide 1 minus. Okay. So let's use that. Valency of potassium 1 plus. Valency of hydroxide 1 minus. So So we don't write -1, we write 1 minus. Now to form the compound, there's a very nice technique. We call that crisscross method. If you don't do the crisscross method, the teacher will do crisscross in your paper, right? So what do we do here? We are just going to exchange these numbers. So this one comes down here, this one goes here. So finally what are we getting? We get K1OH1. So you can leave the plus minus. So you bring down these numbers. Since both are 1, we don't have to write it. So the final answer is going to be KOH. Both basically are valency 1. And you don't have to put the bracket on hydroxide because the number is 1. Potassium hydroxide. So this is the beauty of chemistry, that if you know your symbols, if you know your valency, you can form the formula of pretty much any compound just by switching the valency numbers. So put this number here, you put this number here, done. Because this means how powerful it is, how many other atoms can it combine with. Let's look at the other example, magnesium hydroxide. So magnesium hydroxide, what is it? So magnesium has valency 2 plus. Hydroxide has valency 1 minus. We are going to switch this. Actually, you don't have to write the plus minus sign, right? You don't need to write that. So 1 minus. Now let's do the crisscross. So 2 comes here, 1 goes there. So finally we are going to get Mg1OH2. Now some of you might be thinking, why did I put the brackets? Because the number is now greater than 1, 2. The whole thing in bracket, like we write in mathematics. So Mg1OH2. But the 1 is not necessary, so we are going to write the final answers. Magnesium hydroxide MgOH whole twice. Done. Super. Many of you have given the correct answer. So see, using the symbols valency, we have got the formula of the compound. Let's try another one. Cuprous oxide. And then there is cupric oxide. So copper is one guy which has multiple valencies. So if you guys take a look here, where is copper in this list? Copper has valency 1 and copper has valency 2. Always cuprous, the us means lower valency, ic means higher, like ferrous, ferric. So valency 1, valency 2. So let's apply that. So if we take a look at cuprous oxide, so what is it going to be here? Cuprous, copper with valency 1. This time I won't write the plus minus. Oxygen valency 2. Now do the crisscross. So we are going to get Cu2O. O1, but we don't have to write 1. So cuprous oxide is going to be Cu2O. Do you guys agree and follow me there? Cuprous oxide is going to be Cu2O. Clear? Let's take a look at the next one. Cupric oxide. Cupric means copper with valency 2, oxygen valency 2. Let's do the crisscross. So what do we guys get? We are going to get Cu2O2. Now the question is, should we leave it like this? I've just switched the numbers. I brought this 2 here, this 2 here. I've written it. But now there is one more important rule. If there is any common factor, please divide with that. So you can see clearly we can divide by 2 or it will cancel off. So finally we are going to write it as CuO. Okay. So see, very systematic, very easy. Sometimes we call this one copper 1 oxide or cuprous oxide. This is called cupric oxide or copper 2 oxide. Copper 1 bracket, so we put the 1 in Roman numerals. This one we write 2. The last one is very interesting. Copper oxide. In the book, many times the book just says copper oxide. So are they talking about this one or something else? What do you guys think? So this is where chemistry becomes difficult and irritating. What you need to know is, here you have to know the common valency of copper. So when they just say copper oxide, you need to know which guy is more common, cuprous or cupric, and the answer is cupric oxide. Or you can say think that in the book usually do I see Cu2O or CuO? The answer is usually, if you have not seen, don't worry, but usually you will see CuO. So the correct answer is copper oxide is basically CuO. Why? Because the common valency of copper is 2. Okay. So applying the common valency of copper, we get CO. Let's try another one, sulfur dioxide, sulfur trioxide. Or if I ask you, what is the formula of carbon dioxide? Can you guys tell me? You're breathing out carbon dioxide right now. What is the formula? Now the best part is here, you don't have to know the valency, just by the name, carbon dioxide, CO2, right? You guys have heard of it, CO2. Same way can you do for me, sulfur dioxide? Very simple, SO2, directly from the formula, done. This is a compound. Same way sulfur trioxide, you guys can guess it. Trioxide means it is going to be SO3. So here we don't have to bother too much about valencies. Directly we can write from the name. Similarly, if I ask you carbon monoxide, CO, don't write C1O1, one is not necessary, right? You want to try another one? Write the molecular formula of the following ones. Lead 2 oxide, lead 4 oxide. Again, I'm giving you flavor of what you're going to see in the books, right? So this bracket is what I was talking about. This means valency 2, this means lead with valency 4. So let's go ahead and try it out. So this is basically plumbous oxide, plumbic oxide. So in plumbous oxide, we have lead with valency 2 or 2 plus, oxygen as valency 2. So if you guys bring these down here, do the crisscross, what do we get? We are getting Pb2O2. Is that going to be the final answer? No, remember you have to cancel out the common factor. We can divide by 2. So the final answer is going to be PbO. Common factor 2 cancels. Next one, lead 4 oxide. In lead 4 oxide, you have lead with valency 4, oxygen with valency 2. So now if you do the crisscross, what do you get? Pb2O4. Is my answer correct? Should I leave this answer? Again, look for the common factor. We can divide by 2. So the answer is going to be therefore PbO2. Excellent. Any other name for this? Lead dioxide. Can you see? Lead dioxide. This is lead monoxide. But here it was easy to work out from because they gave us the valency. In Roman numerals, the valency is written. Lead 2 oxide, lead 4 oxide. So now let's talk about changes in our everyday lives. So we know that changes are happening all the time, right? And for example, if you consider cooking going on, or melting of ice, ripening of tomatoes, or now is mango season, ripening of mangoes. So can you guys tell me what are the physical and chemical changes that you see here? What is the main difference? Do you guys remember the difference between physical and chemical change? So in physical change, the important thing is no new substance is formed. Okay, and usually the physical changes are reversible. But in chemical change, the important thing is something new, some new substance has to be formed and they are irreversible. Okay, so physical changes, nothing new formed, usually reversible. You can have some irreversible cases like breaking of glass, but usually they are reversible. And chemical changes, something new has to be formed and they are irreversible. So with that in mind, can you guys tell me, cooking of food, is it physical change or chemical change? What do you guys think? Excellent, absolutely right answer. Cooking of food is so for chemical, I'm going to put C, and for physical, I'm going to put a P. So cooking of food, definitely chemical change, because you know something new is being formed. Like you can say the atta is being turned into a paratha, right? Or whatever, when you're cooking, let's say whatever dish you're cooking, once it is cooked, you cannot get back to the raw ingredients. So cooking, definitely a chemical change. Now what about melting of ice? So here you see in the picture melting of ice, physical or chemical. So even though the solid is changing into a liquid, there is a change happening, solid to liquid. But we know ice is just made of water or water molecules. So there is no chemical change. The substance is remaining the same, which is water. So this is definitely a physical change. Melting of ice, physical change. Ripening of tomatoes or ripening of mangoes. So you can see that some chemical reaction is happening, something new is happening, right? So in chemical change, a chemical reaction is involved and you cannot get back, you cannot reverse it. So definitely this is a chemical change. So apply your science knowledge, right? Apply your science logic here. What about boiling of water? So let's say you're making tea and you're boiling water here. So physical or chemical? Again, there is a state change. It is going from liquid to gas, but there is no new substance being formed. Steam is just water after all, only in vapor form. So this is again, physical change is the right answer, right? Physical change. What do you see in this picture? Rusting of iron. You know, iron, this is a big problem that due to water, air and moisture, it rusts. And when it rusts, the iron forms a compound ferric oxide, which is hydrated ferric oxide. So a chemical reaction happens, something new is formed. It is irreversible and absolutely right. The correct answer is chemical change. Next one, burning of this candle. So what do you guys think is the answer for this one? Physical or chemical? Superb, you guys gave the right answer. It is both physical and chemical. Why? Because see, burning is definitely a chemical change. That wax is burning, the hydrocarbon is burning to produce carbon dioxide, water, heat and light, right? So this is definitely a chemical change, the burning of the candle. But when the candle is burning, due to that heat, you can see the wax starts melting. So the wax is changing from solid to liquid state, but it is still wax. So there is a physical part also involved there. So this is a very interesting everyday life example where you have both physical and chemical change. So now in chemistry part, which is important for us, physical or chemical changes? What is more important in chemistry? Of course, both are important, but in chemistry, we are more concerned with chemical changes because a chemical reaction is happening. Okay, something new is being formed, chemical reaction is happening, and that is why usually you are studying chemical changes, and we write chemical equations to represent the reactions. So this is the important thing for you guys to know this concept. In a chemical change, a chemical reaction is taking place. So when you have a chemical change, there will be a chemical reaction. Now, what is a chemical reaction? It is a process. As we said, the new substances are formed. So something new has to be formed. New substances with new properties are formed. For example, if you take a look at these reactions that we have written, hydrogen and oxygen, you know, if you burn them, what does it produce? It forms water. So clearly water is the new substance here. And is the property of water different from hydrogen and oxygen? What do you guys think? So this is the magic of chemistry, because if you look at the properties of hydrogen, hydrogen is a gas that burns. It is a combustible gas, right? And oxygen is a guy who supports combustion. So look at the situation. Hydrogen burns and oxygen supports combustion. So this burns, you know, quite explosively. But when the product is formed, water, we use water to extinguish fire. So water does not support burning. And in fact, these are gases, and when you condense them, it forms a liquid. So can you see how the properties are changing? The entire chemical properties are changing. So this is the magic of chemistry. You can't even predict what you're going to get. Hydrogen, oxygen giving water. Same way, sodium plus chlorine gives sodium chloride. If I give you guys sodium is a metal. If I give you guys some sodium, would you like to eat that metal? If I give you right now, will you eat it? Yes or no? Obviously not. You don't want to eat the metal, right? If I put you in a room of chlorine gas, will you like it? Will you survive? No, chlorine is highly poisonous. Okay? So, chlorine gas is bad. But when this metal sodium and this poisonous gas chlorine combine, what do they form? Sodium chloride. Have you guys eaten sodium chloride? We eat it every day. It is our table salt. The salt is made up of sodium chloride. So again, the magic of chemistry. Metal and a poisonous gas is giving you salt that you eat every day. So this is the beauty of chemical reactions, that some new substance has to be formed with new properties. Typically, it will have new properties and it's completely new. This means a chemical change or a chemical reaction has taken place. Can you just get water by mixing hydrogen and oxygen? No. So we have to do, we have to ignite them. So you have to provide the correct conditions for the reaction to occur. You cannot just mix two things and say, hey, I formed a chemical reaction. Sometimes it will happen spontaneously. Sometimes we need to provide energy in the form of heat or light or some form of energy to start the reaction. So when you guys look at this chemical reaction, again, if you have not seen them, don't worry. These are coming up in chemistry like We have written it in simple words, right? Hydrogen plus oxygen forms water. So what are the substances on the left known as? Can you guys tell me? What do we call these guys on the left of the reaction? Left means it's like an equation, right? Hydrogen plus oxygen, then you typically draw this arrow. Some books write equal to, but I like to draw the arrow and then you write water. So these things which you do the reaction with, these are called reactants. So let's write that down. The guys on the left are called the reactants. So here hydrogen and oxygen are the reactants of the chemical reaction. And what are these guys on the right called? Water. So here we have only one substance. These are known as products of the reaction. Similarly here, if you mix iron and sulfuric acid, if you make them react, this produces iron sulfate and hydrogen. So what are these guys on the left, or who are our reactants? Iron and sulfuric acid. And these guys on the right, they are the products, iron sulfate and hydrogen. So please remember this terminology. What substances react in the chemical reaction, they are written on the left, they are called reactants. And then you put that arrow, and what is produced, one or more things that are produced substances, those are known as products. Now usually you won't find this written in the chemistry books. This, when we write it like this in words, in simple words, this is called a word equation. But we are learning the language of chemistry. We want to be chemistry experts. So we don't want to write in simple English, we want to use the symbols. So one very important thing, again I'm doing it with very simple things, so that when you pick up the chemistry textbook, my goal is it should not seem scary to you. It should seem much easier, okay? So what is our goal here? We want to convert this word equation, like hydrogen plus oxygen plus water, to a simple chemical equation. Now there are some rules to do that, okay? For example, if I want to convert this, can I simply do something like this? Can I just use symbols? So if I write H plus O gives me H2O. Have I done my chemistry job? Is it correct? Have I done the right thing here? That H plus O is H2O? No, you guys are saying no. Why? Because again, there are some rules here. So what is one important rule? That when we represent these substances in a chemical reaction, typically all the reactants are products we represent in terms of molecules. Why? Because like we discussed in the last class, atom may or may not be stable, but molecules are always stable. That is why this world, the matter exists in terms of molecules. Like we are breathing in molecules of oxygen right now. The nitrogen in this room, right? 78% of air is nitrogen. It's in the form of N2, nitrogen molecules. So we cannot just write this because these represent only one atom. Okay, so we should not represent the atoms of the substances, we should write it in terms of their molecules. So this is one very important thing, that all chemical equations, or usually most of the chemical equations that we are going to be talking about, of course ionic equations are a bit different. Usually we represent the substances in their molecular forms. So this is an important note here. Substances should be written in terms of molecules. So let's go ahead and do that. So how do I represent one molecule of hydrogen? Hydrogen is an element, it's not a compound. We know the symbol is H, but for elements we should use atomicity. So one molecule we know, hydrogen is diatomic. How do I know? You have to learn this, okay? There is a reason why it is diatomic, but for now, let's learn that hydrogen is a diatomic gas. So we are represented as H2. So I'm going to write this as H2. What about oxygen? Oxygen is also an element, and again like hydrogen it is diatomic, so we will represent it as O2. And water is a compound, right? So water we are going to represent it in terms of its molecule, H2O. Clear? So this is the important thing you need to know, that when you are representing the substances in a chemical reaction, you need to write it in terms of their molecules, not in terms of atoms. And ions will come to those ionic equations just like this. So now we have correctly converted our word equation, and this is called a chemical equation. Clear? Is this the final equation? Is there something missing, or is this the right answer? What do you guys think? Yes, till now everything is right, except it needs to be balanced. So don't worry, we'll also be learning about balancing of chemical equations. So if you guys know that the number of atoms on each side should be equal. So you can see hydrogen, there are 2 atoms, there are 2 here, but oxygen, there are 2 atoms and only 1 on the left. So one oxygen atom can't just run away out of this class, right? It can't say, I don't like language of chemistry, I'm going out. Please don't do that, okay? So oxygen, it cannot go from 2 to 1. So we actually have to balance, and we learn all that. Just to give you a flavor here, since there's only one oxygen atom, I need to multiply by 2 here. Similarly, now there are 2 times 2, 4 hydrogens, so I need to multiply by 2 here. So you will need to do the balancing as well. But for now, I'll leave out the balancing. In this simple example, we are just converting word to a chemical equation. Okay, if you guys want, I'll write the balanced equation as well. So we can write it as 2H2 plus O2 gives 2H2O. And this one is balanced. Now, why don't you guys try this one? It doesn't matter if you get it right or wrong. Please try. How will you change this word equation to a chemical equation? Again, do it systematically, and remember, we have to change every substance. We have to represent it in terms of molecules. And please remember again that atom, for the elements, we use atomicity. For molecules, for the compounds, we use valency. So everybody please try. So we'll start with sodium. Sodium, is it an element or compound? Sodium is an element. We cannot break it down further. So for elements, we are going to use atomicity. What is the symbol of sodium? Na. Okay. So let me write first, you write it in terms of symbols, Na. Now you think, what is the atomicity of sodium? Remember we said all metals are monoatomic. One molecule is one atom. So we don't have to write Na1. We can simply write Na over here. Okay. Next one, chlorine. Chlorine, is it an element or compound? Chlorine is an element. What is its symbol? Capital C, small l. Okay. And what is the atomicity of chlorine? Diatomic. Atomicity is 2. So I'm going to write Na plus Cl2. So this part is clear. Now if you look at sodium chloride. Sodium chloride is a compound. For compounds we use valency. Valency for compounds. So NaCl, sodium valency 1, chlorine valency 1. So if you do the crisscross, you're going to get NaCl. Okay, simple. So there you can see, so simple. That's how you convert a word equation to a chemical equation. No big deal. The only thing is you have to learn all those symbols, atomicity, valencies. That's it. But now at least you're getting the flavor of what the chemical equation looks like. And of course, the last thing is we have to check the balancing. See, sodium is balanced, one atom here, one here. But chlorine is 2 atoms here, only one here. So I need to multiply this entire thing by 2. So chlorine gets balanced, but sodium is 2 now, only one there. So I need to put a 2 here. And we are done. You guys want to try this one? Word equation to chemical equation. And don't worry, balancing details we'll be doing in other classes as well. So what is our equation here? Iron plus sulfuric acid gives us ferrous sulfate plus hydrogen. Again, go step by step. Remember, you have to represent it in terms of molecules using atomicity for elements and valency for compounds. That's it. That's all. Okay. So let's start off one by one. Iron, what is the symbol of iron? Iron is not I. I is for iodine. So iron I'm going to represent as Fe. Since iron is an element, we'll use atomicity. What is the atomicity of iron? Iron is a metal. All metals monoatomic. So we don't have to write Fe1, Fe is fine. Plus sulfuric acid. So here you need to know sulfuric acid is made up of hydrogen and sulfate. So let's find the formula. Sulfuric acid is made of hydrogen and sulfate. It's a compound. Hydrogen valency 1, sulfate valency 2. So can you guys do the crisscross for me? Simple. So 2 comes here, 1 goes there. So we are going to get Fe plus H2SO4, and then you put the arrow. Here it says ferrous sulfate plus hydrogen. So what is the formula of ferrous sulfate? So again, ferrous sulfate means iron and sulfate. Ferrous means iron with valency 2 because ferric means iron with valency 3. Iron can have multiple valencies. So ferrous sulfate means valency 2. Sulfate also has valency 2. So if you guys do the crisscross, the 2 and 2 will cancel. So we'll simply get FeSO4 plus hydrogen. Hydrogen symbol capital H. So should I leave it like this? But remember, hydrogen is an element. Remember atomicity. Atomicity, valency numbers, please learn separately. So what is the atomicity of hydrogen? 2. So let's put it down here. H2. There you go. We are done. So Fe plus H2SO4 gives ferrous sulfate plus hydrogen, and please check if it is balanced or not. So you can see iron is balanced, H2 balanced, sulfate balanced, so that's great. You don't have to do any balancing here. So iron was valency 2, sulfate was 2. So if you guys are thinking here, what happened? So by crisscross, the 2 came down, but this 2 is common, so it gets cancelled. So that is why the final formula is FeSO4. So if you learn these atomicity, valency symbols, you can pretty much write these equations, or you can start writing them. And then with practice, you'll find it very easy. So I hope you guys enjoyed this class on language of chemistry and got a flavor of what you're going to see in the books. Even if you don't understand each and every concept, don't worry, we are going to do it in the course. But please make it a habit to start learning those symbols, atomicity, valencies, whenever it comes up in your school or in your books, or earlier you learn it better, you will start finding chemistry very easy because now you can speak that language. It's just like, if you go for a trip to France or Germany, if you learn some French, your trip will be more enjoyable, right? You'll be able to speak to the people. Same way in chemistry, you don't have to master the whole language at once. Start learning it and you will find chemistry much more enjoyable to study. So that was my goal, to remove that fear of chemistry, because when I was a student, first time I picked up the chemistry book, it looked like, oh my God, what is all this? It looked like some different language, right? And that is what we are learning, the language of chemistry. So hope you guys enjoyed the class, and do check out the other courses on our website. We have physics, chemistry, biology, and maths for CBSE class 8, 9, and 10. So do share out our courses with your friends. For ICC students, again, we have physics, chemistry, biology, and maths for classes 8, 9, and 10. And if you want to learn coding, we have Python programming, we have Java coding. So these awesome coding courses are there. And we have physics and chemistry for the Cambridge IGCSE board. So do share out our courses with your friends. Make sure you have subscribed to our YouTube channel. We also have our Facebook and Instagram page. You can follow us there. So stay connected and keep learning.